functions. Okay? For grade 12, we concentrate on 3 types of functions and their inverses. The linear function, which is a one-to-one function based on the lesson we had on Saturday. Then the quadratic function, which is a many-to-one function. And then we'll also do the exponential function and its inverse. Right? So those are the 3 functions. So today we'll introduce the linear function. Also be aware that later in the afternoon we are meeting again. I hope you are aware of it.
No.
Yes. Based on the recovery program.
Oh.
It's day 4, lesson 4. Okay. All right. So first, before you start writing anything down, you write the heading, right? I need to define what's an inverse. Okay? What's an inverse of a function? Now, the inverse of a function is a rule, okay, that does, it is a rule that does the opposite. Okay, it's a rule that does the opposite. I think I forgot to put the word opposite there. Right? My friends? Right? It's a rule that does the opposite of the original function. Okay? The inverse of a function is a rule that does the opposite of the original function. Please be aware that by rule we are saying it's an equation. Okay? We can write the equation of the inverse. And that equation does the opposite of what the equation of the original function does. Okay? So copy down the main heading, then the definition. Quickly, please. Hey. Copy down the heading and then the simple definition of an inverse function. All right. Can I have your attention? Can I have your attention, please? So, I hope you copy down the heading, then that simple definition of an inverse of a function. Right? I just want to repeat again. The inverse of a function is a rule that does the opposite to the original function. Okay? Now, let's just do an illustration using a simple example. Now, consider the function f of x equal to 3x plus 1. Okay? Remember, you are in grade 12, so you have done functions. You want me to allow you to go outside? All right. So consider the function f of x equal to 3x plus 1. That's the linear function, right? Now, when you are dealing with inverses, okay, always if you want to find the inverse, you replace the function notation by y, which is something that you already know. Okay? At grade 12 level, you are supposed to know that f of x is the same as y. So f of x equal to 3x plus 1 can be written as y equal to 3x plus 1. Okay? I'm going to repeat that. Please look and listen. F of x equal to 3x plus 1 can be written as y equal to 3x plus 1. Okay? Please, just to remind you, in maths, f of x is the same as 1. If you see g of x, it's also 1. If you see h of x, it's also 1. So don't get confused. F of x is the same as 1.
So it's like polynomial.
Let's not introduce polynomial. Yes, the expression on the right hand side, it's a polynomial. But the lesson is not on polynomials. We've done polynomials in the lower grades. Again, our next topic after this, we'll talk about polynomials as well. So this is function notation. You were introduced to function notation in grade 10. So f of x is the same as what? All right? Then I decided to choose x equal to 2 and substitute it into the equation. So f2 is the same as 3 times 2 plus 1. That will give you 6 plus 1, which is a 7. So I substituted x equal to 2 into the equation, and then I got 7. So the 7 is a y value. The 2 is an x value. Alright? Yeah, all these are basics that you should know at this stage. Then, now if I bring in the concept of the inverse of f of x equal to 3x plus 1 will transform or change 7 back to 2. The original function transforms 2 to 7. Its inverse transforms the 7 back to 2. What does that mean? Well, it means that for the inverse, the y value of the original becomes the x value. The x value of the original function becomes the y value.
So what you substitute to?
I just chose one value. We can't choose many. I just chose one to just illustrate this part. You can choose another value. So let's say choose 5. Put 5 here. You get 16 there where there's a 7. Which means the 16 will be the y value for the original function. The 5 will be your x. For the inverse now, the 16 becomes the x value and the 5 becomes the y value. Alright? So the inverse of a function transforms the y value into transform the y value of the original function into an x value of that inverse. Alright? Now, if you want to determine the inverse of a function, the first step is what I showed you here. You convert, or rather you replace the f of x by y. That's the first step. Then the next step, you interchange x and y. Okay? You interchange x and y. Then after that, you make y the subject. So you replace f of x by y, you interchange x and y, then you make y the subject. I'll show you just now on the next page. Okay? The word inverse, if you want to generalize it, it means the opposite. That's all. Okay? So for the original function, if a value is an x value, that value will become the y value for the inverse function. If a value is a y value for the original function, it will become an x value for the inverse. So it means there is an interchange of x and y part. Okay? Can you copy these 2 points? Copy down those 2 points quickly. This one here and that one. Okay,
So can you put in
let me move on to the next page. Right, if you are behind, you can take your Yeah, but you need to understand what you're copying. All right. Okay, that's where the teacher comes in. Okay, the inverse of a function is denoted by f of minus 1 of x. This is the notation used for the inverse of a function. The notation used is f of minus 1 of x. Okay? So for the inverse, we will no longer use f of x, but we will now use f of minus 1 of x. So this is a new notation which is introduced in grade 12 to represent the equation of the inverse of a function. Okay? That's what I'll show you just now. So for the previous equation which I had, the equation was f of x equal to 3x plus 1. Right? If I want to find the inverse, can you look and listen? If I want to find the inverse of f of x, first thing I have to replace f of x by 1. Okay? So that the equation looks like a grade 9 linear function. Okay? So the equation is now y equal to 3x plus 1. Then we have to interchange x and y. Now this is important. We have to interchange, or maybe let me use the word swap. Swap x and y. So you have to swap x and y. So this y here becomes x, that x there becomes y. Okay? So that the equation becomes x equal to 3y plus 1. Then in maths you should know that always we make y the subject because it's a dependent variable, it's an output. So we make y the subject. If you make y the subject, you take the 1 to the left, you get x minus 1 equal to 3y. Then you divide every term on the left and the right by 3. You come to a third x minus a third equal to 1. Then we replace this y here by the function notation. Okay, so the equation will become y equal to the third x minus a third, and then we replace this y here by f of minus 1 of x, so that we'll get our equation of the inverse. Okay? So this is now the equation of the inverse. It's not the original equation. So this is the equation of the inverse. Yes. Okay, I'm going to be talking about that step of converting the function to its inverse. First step, generally you'll be given the function in function notation. That's the most common. So convert f of x, or rather replace f of x by y, right? Then swap x and y. You just swap the x and y. The y becomes x, the x becomes what? Y. Yes, it's in negative a third. Okay. Can you look here? Can you look? So from here, we're following that. So we swap x and y, right? Then we make y the subject. So right here, make y the subject. Yes. That's the procedure. So you start by replacing f of x by y, then you swap x and y, then you make y the subject. Okay? So if you make y the subject, you get to this point. Y equal to a third x minus a third. So can you put your device away, please? Put it away. Okay? So you get that. Then you replace the y by f of minus 1 of x. F of minus 1 of x is the function notation of the inverse of a function. Right? So we stop here. Now, the next thing on the next page, we are going to sketch these two graphs, the graph of the inverse and the original function. But before we do that, let's just do a quick analysis of some of the important things that you might need to know. So for the original function f of x, the gradient is 3. Right? The gradient is what? 3. For the inverse, the gradient is a third. From your grade 8 and 9, what is the relationship between m equal to 3 and n equal to 10? Yes.
3 is equal to 3 over 1, and 1 over 3 and 9. We change the exponents.
You're almost there. Right? Remember, we were taught that reciprocals of inverses of numbers. Grade 9. So m, 3 is the inverse of 1 over 3. Okay? Remember the denominator here, like what Tando said, the denominator there is a what? It's a 1. So if you invert 3 over 1, you get 1 over 3. There is a relationship there. The 2, that is this 3 and the third, they are inverses of each other. Good? That's in. Or you can say a third is a reciprocal of 3. If you didn't get either the word reciprocal or the word inverse, something is wrong. Okay? The reciprocal of 3 is 1 over 3. The reciprocal of 1 over 3 is a 3. Maybe you forgot because it's been 3-4 years now. Okay? Then the y-intercept of f of x is a 1, and the y-intercept of the inverse is negative a third. Well, I will talk about that later on. But do you agree with me that this one here, that's the y-intercept of the original, and that negative a third is also the y-intercept of the inverse. Now I'll show you something very interesting on the graph. Right, any questions so far here? Any question? Any questions so far? Today you have to be ready to digest quite a lot of things. All right, let's move on to the next page. Now, next page, pay attention. Now, let's draw the table of values now. of the two. That is the original function and the inverse function, the table of values. So generally, we start with the table of values of the original function. So I chose 4 values of x. Okay, I chose 4. The 4 that I chose for the original are x is -1, 0, 1, 2. So if you substitute those values into the equation, you get y equal to -2. Yes?
Do you get like the tables and the values?
No. Right? The reason why I chose those 4 is just to not waste time by having too many values of x. So I chose 4. Can you pay attention? So if you substitute x equal to -1, you get y equal to -2. X equal to 0, you get y equal to 1. X equal to 1, you get y equal to 4. X equal to 2, you get y equal to 7. Now remember what I said earlier, okay, when I was on the previous page. The concept of the inverse involves swapping x and y. That's the concept. So these x values there will become the y values of the inverse. If I ask you now and say, substitute these x values into the equation of the inverse, you will get these values. And remember, if you put an input, that's x, okay? If you get an output, that's y. So if you substitute the x values, these x values into the inverse, you get those y values. Okay, like example, if you put x equal to -1 here, and x equal to -1, if you solve, you end up getting your y is -1. The x values become the y values. Okay? Are you following? Then the y values, okay? The y values become the x values. So these y values become the x values. So if you substitute, you see these values there, into the equation of the inverse, you get those x values. So the y becomes x, the x becomes y. Okay? So it will be like this: x becomes y, and y becomes x. That's the concept of the inverse. Any questions so far? Tombela? Hey, can you move these pencil cases? You put away the device. Probably you think maybe I don't know the tricks. I know the tricks because I've been using. Okay. Right, let's sketch now the two functions. Now, when you are sketching linear functions, do you remember the method that we were taught in grade 9?
Yes.
What was the method called? Because we're taught two methods. How to sketch a straight line. There's a gradient intercept method and the dual intercept method. Thank you. Alright? So we are going to use the dual intercept method. By dual intercept means we have to determine the x and y intercepts of both graphs. Okay? All straight lines pass through the intercepts. So let's start with the f of x, right? My y-intercept is 1. I know that. So I'll go to my graph. Okay? It means 1 is here. Can you pay attention and look, please? And then, what is my x-intercept? My x-intercept, I have to put y equal to 0 here. Okay? So if I put 0, where there is y, can you look, please? You get 0 equal to 3x plus 1. Alright? Then to solve this, you end up having minus 1 equal to 3x. Then you divide both sides by 3. So x will be negative a third. Okay? So the x-intercept will be negative a third. So we go to the graph. I'm going to approximate my negative a third somewhere there. How do you find the x-intercept? So if you put 0 here, you get 0 equals 3x plus 1. Then, if you want to make x the subject, you take the 1 to the left, it becomes minus 1. Then you divide both sides by what? The coefficient of x, which is a 3. And you get x equals minus a third. Mundis, are you okay? Huh? If your equation is y equals to 3x plus 1, if you put y equal to 0 here, how do you solve for x? Okay, let me get on. Right, please. Okay, this is not a laughing thing. At this stage, can I have your attention? I expect everybody to know how to work with this. You understand? Yeah. No, I expect you. This is not grade 12, by the way. Okay. No, I understand. I also understand. That's why I said, are you okay? Okay. All right. Okay. Listen. So we've got x equal to minus a third. Right? Then we go to the graph. In this case, I had to approximate the position of minus a third. So it's somewhere there. Then I need to draw my graph. Okay, make sure you look well. Let me use blue for that. So I'll start somewhere at the bottom here. And then I'll draw my straight line. Okay. Let me just move it a little bit to the left. Okay. And then maybe a little bit, right? Well, it's a little bit of a challenge. But it's something like that. Okay? So, Lucy, so this is my straight line. Then I need to label it. Okay? So, that will be f of x equal to 3x plus 1. We are doing grade 9 work, some of the stuff that I'm doing. Right? We are sketching a straight line. To sketch a straight line, you use the dual intercept method. That's the easiest way. Right? So I identified my y-intercept and x-intercept. Then in your case, use a ruler to join those 2 points by drawing a straight line beyond both intercepts. Okay, so I've done that. Then let's find the x and y intercept of the inverse. Right? If you have got this equation, okay, this equation here, if you put, I'm sure you can agree with me that already the y-intercept is that. What's the y-intercept? Am I talking to myself? If the equation is in the form y got mx plus c, it means that constant there is going to be the what? The y-intercept. It's negative a third. Right? It's negative a third. But it's a y-intercept. So it will be somewhere there. Right? Then, if I want to get the x-intercept, I have to substitute the f of minus 1 of x by 0. Okay, can you look here? So if I put 0 there, it will be equal to a third x minus a third. Right? Can you look, please? 0 is equal to a third x minus a third. Then I'll take the negative a third to the right. I'll get a third is equal to, I can write this as x over 3. I hope you are aware that a third x is the same as 1 over 3. Sorry, is the same as x over 3. Right? Then, since the denominator is the same, it means the numerators are what? Are the same. So x will be equal to 1. Okay? So x equal to 1 is there. Are you following?
Yes.
Right, then let's join those two. Now if I want to join those two, I need to be very careful. Okay, let me change the color. This color here. Maybe this time I'll choose that one. Right? Okay. So I just have to join. So I just have to join those two dots. So this will be equal to okay. So it looks like that. But maybe I can just move it slightly. The top, and then this side I'll move it slightly down. Let me move up. Let me move up. Okay.
She must rest.
Okay, maybe let me move it. Okay. All right. Can I have your attention? So we have our two graphs. Then I need to label the inverse is f of minus 1 of x equal to a third x minus a third. Now check this. Can I have your attention, please? Can I have your attention? Do you see that the y-intercept, which was a 1 for the original function, which is in blue, is now the value of the x-intercept for the inverse? Do you see that?
Yes.
Right? Then for the x-intercept of the original function, it was negative a third. Now, that value is the y-intercept of the inverse. So there is a swap which took place of x and y what? Values. Alright? Then, when you are doing this topic, you need to be aware that these two graphs, they are mirror images of each other about the line y equal to x. So allow me to also sketch the line y equal to x, which passes through the intersection of the two graphs. So I don't have a ruler, so I'm going to use my free hand and make sure that my line y equal to x passes through two critical points. So let me use that. The two critical points are the origin and the intersection of the two graphs. Okay? So the two, that is f of x and f of minus 1 of x, are mirror images of each other about the line y equal to x. Okay? So this is the line y equal to x. Okay? Then we need to know what is the domain and what is the range of both functions. Okay? So the domain of f of x is going to be x is an element of real numbers. Because we are starting from minus infinity down there all the way up to positive infinity. For the range, we are starting from minus infinity down there all the way up to positive infinity. So it will also be y. It will be y is an element of real numbers. That's for the original function f of x. For the inverse, okay? For the inverse, the domain, remember, the domain of the original function becomes the range of the inverse. And the range of the original function becomes the domain of the inverse. So this range here, we just replace that y by x. So we end up writing x is an element of real numbers. For the range, the x values here become the y values. So we replace this x by 1. We get y is an element of real numbers. Okay? So that's what you are supposed to have. Are you following? Huh? Okay. So your class exercise. Class exercise. Can you write class exercise after this graph, please? Your class exercise, please write this down. Sketch the graph of, please write what I'm saying down. Sketch the graph of f of x. Sketch the graph of f of x equal to minus 3x plus 6. Sketch the graph of f of x equal to minus 3x plus 6. Okay, and its inverse. Sketch the graphs, please just make it plural. Sketch the graphs of f of x equal to 3x minus 3x plus 6 and its inverse. Okay, can you start working on that? Start working on that. Our lesson we are gonna carry on later, but I need to see before the bell rings whether you have determined the inverse of f of x. What? Hey, can you find the inverse of f of x first? And come and show me quickly. What? Okay. Tando, this is a class exercise. Okay? There is no homework yet. It's a class exercise. Okay. So I expect you, listen, you won't go out without showing me the inverse. Okay? No break for you. If you don't come forward and show me the equation of the inverse, no break for you. You stay here. Can you find the equation of the inverse? For now, Then you need to carry on after that. Can you come and show me the equation? Forward. Okay, now help you. No, you don't have to tell me what you are doing. There are lots of things that can be done in the table. You don't have to say it. Yeah, but Bayanda, you won't go for break if you don't show me your equation of the inverse. Yes? You're wasting time. Negative 3x plus 6. Find the inverse of f of x equal to negative 3x plus 6. You must come and show me the equation of your inverse. If you determine, listen, if you found your inverse, then you must come forward and show me.